Hi, this is Daniel Burr. I'm going to do a two proportion, two sample proportion hypothesis test for this discussion here. So I chose this one from module 6.3. It's problem 1. You can see all that. Okay, so here we go. It's a manufacturer withdrew drug V from the market after a study revealed it was associated with an increase in the risk of heart attack. Skip ahead a little bit. For the people taking drug V, for that population, there were 46 heart attacks out of the 1,297 people in the sample. And for the placebo, there were 25 heart attacks out of 1,257 people taking the placebo. So we want to perform a hypothesis test. We should make sure all our conditions are met, even though the question doesn't ask us that. Our samples are large enough. We can see that. There's at least, so 25, there has to be 10 successes, 10 failures. And we can see that that's met just by looking at the numbers there. And then we also want to make sure that our samples are random, independent samples, and then independent within samples. All this language right here, the placebo-controlled, randomized, and double-blind, that tells us that those conditions are met pretty well. And then we also assume that the null hypothesis is true. So let me scroll back up here. We know that the null hypothesis, wow, that's going slow. The null hypothesis in this case would be that the proportions are equal for each of these populations, thus meaning that drug V doesn't cause an increased risk of heart attack. It's just the same as the placebo. So our alternative hypothesis, on the other hand, would be that it does cause an increased risk of heart attack. So that would be this option right here. The Z test statistic for this test, I got that from StatCrunch. I already have it pulled up here, but just to run through it, we went to Stat, Proportion Stats, to Sample with Summary, and then typing in the number of successes. It's weird to call a heart attack a success, but that's what they were testing for, so that's what we got to put in that box. So our first one was our drug V, and then there's our placebo. And we want to make sure that P1 greater than P2 is what we're testing for. And that's exactly the same as the first box I made. But there it is, Z stat of 2.39, p-value of 0.008, which is smaller than our significance level of 0.01. So we're going to reject that null hypothesis and conclude that drug V causes an increased risk of heart attack. And then a little added bonus with this one, it was a placebo-controlled randomized double-blind. Those are the conditions under which we can actually use a cause and effect claim. So, thank you for listening.